All right, so today, Unit 9, Area and Perimeter of Geometric Figures. Today we're going to be talking about trapezoids, kites, and rhombus or rhombi. You might hear the word rhombi. Okay?
Rhombuses.
What's that?
That plural.
Yes. Plural for rhombus. So, warm up. We have find the area of this shape. All I want to do is I want you guys to talk through it with me. We're going to do some mental math to start today. And with this one, we're going to try and figure out, hey, what is the area? Okay, so if we take a look at this shape, what is this shape? Do we know the name of this shape yet?
Rhombus.
This is not a rhombus. Okay, this is a quadrilateral. Okay, technically it is a trapezoid, but we don't know that yet. Okay, now could I break this shape up? Would I be able to do that? Yes, right?
I got it.
I put it here. This is 90 degrees. What is the base of that triangle? 2. What is our height? 4. Here comes the mental math. Here we go. What is half of 2?
4.
1 times your height. So the area of the triangle is 4. 1 times 4, right? Half your base times your height. Next, we got our rectangle. 4 times 7 is what?
28.
Okay, what's 28 plus 4? So the area of this figure is 32 feet squared. We didn't have to use a calculator. Okay? Does anyone remember the name of the postulate that would allow us to do what we just did? There was 2 of them. Flip back in your notes. Does anyone have those 2 postulates in your notes from 9.1? Something about composition. Natalie, do you have it? No? Anyone have it? We did it?
I don't think we did 9.1.
Yeah, we did.
We briefly did part of it after.
We did the whole thing. Yeah, we did. So it was a composition one, whatever that one was. Okay? And then what formulas did you use? Okay, we used area of a triangle and area of a rectangle. So those were the 2. Our learning targets for today. Students will be able to calculate the areas of polygons using formulas, including on a coordinate plane. So you got to be able to use a coordinate plane. Some things that you saw from your 9.1 homework is you probably had to use Pythagorean theorem. Maybe you used some special right triangle stuff. Maybe you used some trigonometry. Today we are going to focus on using some trigonometry. So, second learning target. Calculate the area of polygons using formulas, including on a coordinate plane. So we're going to continue with that with our 3 shapes today. And then this is going to be a focus of ours in our last slide, using the exact trig calculations as a way to plug into our calculator. Okay, and I'm going to give you guys a couple tips and tricks when we do this. So here are our next 3, and this is for perimeter. Perimeter of a rhombus is just P is equal to 4 times S because all the sides are the same. A rhombus is a square that is basically kicked to the side. Okay, it is not, it could be a parallelogram. Okay, but what a parallelogram is a shape with 2 parallel sides. This is a parallelogram, but what makes it special is all the sides are the same. Okay, so just add up all your sides or go 4 times S. Trapezoid. A trapezoid is a quadrilateral. It can be a isosceles trapezoid if that is true. An isosceles trapezoid, this side and this side are the same length. In this figure, is this an isosceles trapezoid? It is not, right? How do you find the area of a trapezoid? Add up all the side lengths. For a kite, it is going to be 2 times A plus B. Okay, and I'm going to zoom in just real quick on this one, and then I'll zoom back out so you can look. Okay, this side here and this side here are congruent on a kite, and these 2 sides are congruent. So to save time, they go 2 times the value of A plus B. Okay, so that's what they're doing there. My wife bought a kite for my daughter about 2 years ago, and I had the luxury of putting the piece of crap together. And it was not a good kite. And one of the sides was actually a little bit bigger than the other. And when I went to fly it with my daughter, which was already hard enough with a 2-year-old, the kite came crashing down and almost hit me because one of the sides was not even. So just remember, kites should be even. If they're not and you try and fly one, watch out. Okay, and this will be in the PowerPoint so you can go back in and look at the skeleton notes. Next, we have our area formulas. And what you're going to notice here is that the rhombus and kite formulas are the same. You're multiplying your diagonals together, diagonal 1, diagonal 2, and then you divide by 2. That is true for both rhombus and kite. The area of a trapezoid, this one tends to get a lot of students. A lot of students like to multiply their bases because what do you do with the rhombus and kite? Multiply, right? So what a lot of students do here with A and B, which are your bases, they will multiply them. You need to add your bases, times that by your height, and then divide by 2, or multiply by 1/2. Okay? The last thing that students will forget to do is multiply by 1/2. So that is trapezoid. And once again, you'll have some time to put these in your notes towards the end. You will get to use your formula sheet on your quiz and test, and that's all you get. Okay, so make sure you are filling that out. Any questions with the formulas for area? Pretty cut and dry. All right, so our first example, it says beavers. To prevent beavers from damming a drainage pipe, if you guys have ever seen like fields that have drain pipes that have the water run off from the fields into the ditch, have you guys seen that before?
Yeah.
Yep, okay, it's kind of a new thing in the last 20 years. They tend to put sluice gates at the end of them and open them up or close them because, fun fact, drain tiles in a field are not just for pulling water out of the field, they're for keeping water in. Does that make sense? So the water can sit in the pipes, and then what it does is it keeps the ground soft. So a really dry year, they'll shut the sluice gate, they'll keep water in there, and it's like having water kind of all throughout your field. When it's really wet, they'll open the sluice gate, turn on the pump, and they'll pump water out. So that's kind of a new thing. Animals like to go in there, so they'll put a sluice gate like this on there. And this one is for beavers, because beavers like to go in and mess things up in pipes. So we need to figure out what is the area of this figure, okay? First question you're going to ask yourself, what is the shape? This is a trapezoid, okay? What are the things you need for area of a trapezoid? You need base 1, which is A, okay? Base 2, which is up top there. And then what is the last thing you need? Height, which is right here, okay? If you didn't have that stuff, then you're going to have to, the second question you would ask yourself, hey, how can I get what I need? Am I going to use Pythagorean theorem? Are there right triangles? Are there special right triangles? Is there anything I could get from other dimensions from your diagram? Okay, those are kind of the next steps. But in this case, we got everything we need. For this one, okay, I want you to round, and you're going to type this in your calculator with me, and you can put this in your notes. I'm going to walk through and show you how to set it up. But I am going to show you when you type this in, round at the very last step. Here we go. Area equals 1/2 times 8 plus 16. I'm just going to add them together right away. What's 8 plus 16? 24. That is the area of our bases, or length of our bases, excuse me. we're going to multiply by our height, which is 8 square roots of 2. Okay? What can I do first? When I multiply, I can start anywhere in that process. I'm going to just go 1/2 of 24, which is 12. And I'm going to multiply that by 8 square roots of 2. Does anyone know what 12 times 8 is? 12 times 8. Grab your calculator. 96 square roots of 2 just goes with it. That is your exact answer. 96 square roots of 2, and you could go feet squared. Okay? So if you're like an engineer and you need to be exact, that would be your answer. Okay? Let's type that in our calculator. Everyone type it in. 96 square roots of 2 is equal to roughly what? 135. Let's round to the nearest hundredth. 0.76 feet squared. And that would be your answer. Okay, so exact, rounded, round to the nearest hundredth. Okay, fists of 5, how do we feel on this one? Okay, this one wasn't bad because we had everything we needed. We might have just been a little confused with the square root of 2. Okay? Example 2. We have a rhombus. It tells us it's a rhombus. We need to find the area of a rhombus. How do we find area of a rhombus? Diagonal 1 times diagonal 2. We are not adding them. All divide 2. Correct? Do I have both diagonals? Okay. Right now it's saying that this is 8. Okay, so that means the whole thing is what? So diagonal 1 is 16. Diagonal 2 is 11 times 2, which is 22. I'm going to multiply those. 16 times 22 is equal to 352. And divide that by 2. Your answer is going to be 176 centimeters squared. Okay? If you are confused if this 8 was the full distance of that diagonal, ask me. Okay? Make sure you are asking, like on your quiz and test. But usually, okay, when it is pointing to it, it's going to be the whole thing. In this case, I treated it like half of it. Okay? So usually that 8 will just stand for the full length. Okay? So ask if you're unsure. All right, our next example. This is kind of stepping it up, okay? Now you guys know how to set stuff up. Now we have some algebra involved, okay? So it's going to make it a little more difficult, okay? So one diagonal of a kite is 2 times as long as the other. And in this case, there is a diagram, so it's going to help you out. You might not have a diagram on your quiz or test, so you got to be able to draw this out. So I would draw a kite. I would draw 2x on the right side, and I'd make it a little bit skinnier because that is just going to be x. We also know that the area is 56.25, so I'd box that in because that's a total. So we're going to set this up, and I'm going to set up diagonal 1 times diagonal 2 all over 2 equals my area. Okay? What is my first diagonal? Let's treat that one as the vertical one. 2x times x all over 2 equals 56.25. Okay? What is 2x times x? 2x squared. A lot of students think it's 3x. That would be 2x plus x. Okay, remember rules of exponents. What do you do when you have the same base? You add your exponents, right? What do you do with the leading coefficients out front? The 1 and the 2. There is a 1 in front of the x. You multiply them. So this is going to be 2x squared all over 2 equals 56.25. What happens with the 2's? They cancel out. I'm left with x squared equals 56.25, and what's my last step? Take the square root. All right, someone tell me, actually it's going to be exact if I remember. 7.5. Okay? Jacob, is that my answer? No. What am I looking for? Diagonal. So I'm going to plug 7.5 in here, and it is square inches, so this is 7.5 inches, and this would be 15 inches. That would be your answers. So I'd box those in. Okay? Moving on. For this one, there's a lot of stuff here. What I want to talk about is distance. Is distance ever negative? In football, right? If someone gets sacked behind the line of scrimmage, is that a loss of negative yards? Yes, it is. It's a loss of negative yards, right? Okay. But is the word yards positive? Yes. The word negative in front of it just means the direction you're going, correct? But yards, the word yards is a positive value. Distance can never be negative. Okay? The word in front of it is what makes it negative. In this case, they have, what are these? Can someone tell me what those symbols represent? Absolute value. And what do we know if I had the absolute value of 3? What is my answer? Absolute value of negative 3. 3. Absolute value of 3x. 3x. Absolute value of negative 3x. 3x, right? It's always going to be positive. You don't really mess with your variables inside. Everything is just turned to positive. Okay? So why do they use absolute value? Because they're looking at this shape up here, and they're trying to find the distance from B to C, which if I look down here, I'm going by 3s. So 3, 6, this would be 9. And I'm also trying to find the distance of that base, which is 3, 6, 9, 12, 15, 18, 21. And I'm also finding my height, which is 3, 6, 9, 12, 15. Those are the 3 things I need, okay? And in this case, it's easy to count. But what they like to do and what they like to show is how do you do it algebraically using absolute value, okay? And I'll explain why here in a second, why you'd want to use absolute value. In this case, I would say, hey, just count, right? Just count. Don't waste the time using absolute value. Use your diagram, count, okay? So in this case, we're going to show it algebraically. So this point right here is 9, 3, 6, 9, 12, 15, 18, 21. This one here is 18, 21. Okay, and I'm just going to show one of these. So for BC, it's going to be my 9 and my 18. 9 minus 18 is going to be negative 9. Absolute value of negative 9 is 9. Okay? And you would do that for your bottom base and your height as well. Okay? Key thing to understand. What if your shape was turned something like, and it's not perfect right now. What if your shape was turned perfect like that? Would you be able to count? Like this distance from here to here. Would you be able to count that? No. So you might have to use absolute value. What else could you use? What is that? A right triangle. Do I have a 6 here? I'll use a different color. Do I have 6 here and 9 up top? How could I find my hypotenuse side? I have 2 sides. It's a right triangle. How could I find my third side? Pythagorean theorem. Okay, so this is a right triangle. Use stuff like that when you're solving for side length. Okay, and we're not going to spend the time finding the area, but that's kind of how you work that process. Okay, this is our last slide. This is the challenge that you guys need to solve. These are the 2 tips I like to explain to students when we're doing hard problems. Number 1, round in the very last step in your process. Why is that? Because if you round step 1, you round step 2, you round step 3, could you be off? Yes, if people that worked in at NASA rounded, the guy in that rocket could end up
Rounded.
1,000 miles away from his destination, correct? Because imagine, here's your angle, you're 2 degrees off because you rounded, okay? 10,000 miles away, that's a big difference right here where you're supposed to be, okay? So when we round, round at the very last step. And we're gonna use, I'm gonna show you guys how to do it on the calculator, and then add what you can to the figure. Okay, so here we go. We got 2 problems. We're gonna start with the easier of the 2. Okay, let's solve for the area of this. What is this shape? Trapezoid. Draw this one in your notes. And let's solve for it. Area of a trapezoid is equal to 1/2 your base 1, which is A plus B, times your height. What do I have? What is my bottom base? 20. A lot of students will say, Mr. Kath, it's 15. That's only part of your bottom base. It's 5 plus 15, which is 20 feet. So that is your bottom one. What's your top one? 13. So right now, A equals 1/2 of 13 plus 20, which is 33, times your height. What's half of 33? Can I do that right now? Yes. What's half of 33? Okay, 16.5. Is it like 16.52879, blah, 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 blah? No, right? It's distinct, so I can round. If it was 16.52, that's fine. Use that, okay? But if it's something that goes on forever on your calculator, don't do it. Wait to divide by 2. Do we know our height? Okay, how do I find my height? What type of triangle is this over here, you guys? 30, 60, 90. And if you have trouble looking at a shape and picturing what side is what in that 30, 60, 90, just draw it to the side. I do it all the time. Okay, what side do we have? We have the short side, right? What is the short side compared to the long side? Half. What's the long side compared, or what's your hypotenuse compared to the short side? 2 times, right? So this side is 10. Technically, I don't need that, but I'm just going to throw it in here. That would be your slant height. Okay, so that is 10. That might help us with perimeter, but I don't need that right now. Okay, what is your bottom leg? 5 square roots of 3. Okay, so this is 5 square roots of 3. This is going to be multiplied by 5 square roots 3. Okay, I'm not rounding yet. We've kind of done one like this before. Okay, so what is 16.5 times 5? 82.5 square roots of 3. That is your exact answer, and it would be feet squared. What is that rounded? Roughly 142.89 feet squared. So be able to do both. Okay, on your quiz for this unit, it is okay if you round to the nearest 100. Okay, fists of 5, how do we feel on that one? Special right triangles, you're going to need to know that stuff. You'll get some more practice with those. Okay, our next one. Let's draw this one out. This is going to be our toughest one for today. Okay, what are some things I could add to this shape? First off, what's the shape? It's a kite. So it's going to be area equals 1/2. Excuse me. See, I'm messing it up already. Diagonal 1 times diagonal 2, divide 2. Okay, do I have one diagonal? Yes, it's going to be 8 plus 16, which is what?
24.
So diagonal 1, we'll just say it's 24. Diagonal 2, I am not sure what it is, but we're going to find that here in a second. Okay, and then I'm going to, once we have everything we need, I'm going to change to showing my calculator. I'm going to show you how to plug it in. Okay, what type of triangle do we have? Do we have a special right triangle? Technically, this is a right triangle. Do I have two sides of that triangle? What triangle am I talking about? Probably. Okay, we're going to focus on this one right here. Do I have two sides on that triangle? Nope. Is it a 30, 60, 90? Nope. Is it a 45, 45, 90? Nope. So I can't use special right triangle facts. Can't use Pythagorean theorem. So guess what we get to go to?
Trig.
Trigonometry. Okay? So we're going to set up to solve for this side. I'm going to label it X. Okay? Right now, we're going to figure out what trig function of 40 are we looking at. So I'm starting at 40 degrees, which is this angle down here. Now, compared to that angle, what is 16? What side? Adjacent, opposite, or hypotenuse? Adjacent. X is what?
Opposite.
OPP. Which one deals with opposite and adjacent? Tangent, TOA, right? So tangent of 40 equals TOA, opposite over adjacent. So opposite is X, adjacent is 16. This one's the easy of the process we took before. How do you solve for X? Multiply by 16. And that's what X equals. So X equals 16 tangent of 40. Now, that is only this X right here, and we need this as well, right here. Is that going to be the same as X? Yes. Yes, it will be. Okay? What does that mean? This right here and this are the same in every kite. Otherwise, it's not a kite. It's a trapezoid. Okay? So what can I do with my value of X? Okay, you're going to double it. So all you need to double is the leading coefficient out front. So your diagonal 2 is going to be 32 tangent of 40. Do I have everything I need? Yes. Now we're going to revert to showing you guys how to plug it in. Okay, and you guys will have to help me out a little bit with remembering what's what. Okay, here we go. So grab your calculator. What is diagonal 1? 24. We're going to multiply by our next diagonal. I want to put this in parentheses so that I can keep it together. Okay? And it is 32 tangent of 40. Correct? I'm going to close out the 40. And I'm going to close out the 32 tangent of 40. Does that make sense? So I had to do double parentheses there. Okay, and I'm going to hit enter. And I get 644.4285167. I am not rounding. Okay, what is my last step for my area formula? Divide by 2. Okay, the fastest thing you can do after you type that in to keep it exact, just hit divide 2. And it's going to say answer divide 2. What's that doing? It is keeping the exact answer and then dividing by 2. Hit enter. Now we can round. So the area of that kite is about 322.21, whatever the units are squared. Okay, if you wanted it exact, you would go 24 times 32. Divide that by 2, and you're going to get 384 tangent of 40, and you're going to get the same exact thing. If you don't know what I did right there, just follow the first thing I did. Okay, any questions? This is a learning target. You got to be able to do it. You round the last step, plug in your trig ratio and values to allow you to figure out your answer. Okay. That's all we got for today.